Hey Haley, how'd you go yesterday? Did you end up sorting out your technical stuff? No. Do you have like an iPhone or anything like that? If you have an iPhone or some kind of Apple device, I can show you how to set up your school email address via that. Alright, let me show you how to. Let me send this message and I'll show you how to set up school email via your phone, so you can just email. Is that music super loud on your end that I've got in the background? So I can turn that down. Yeah, okay, right. Alright. How's that? Is that better? Alright, let's pull up this. Okay. Alright. Hopefully my thing is working today. Yeah, cool. Alright. Let's lock you. Let's fix you up. And then I'll show you how to attach your email. So, I'm doing it on my iPad, but it should be pretty similar to the same, pretty similar to the iPhone as well too. So you go into over here. Okay. So you go into settings. So look for your settings. Go to mail. No, where is it? That's right. No, I'm pretty sure that's right. Go to accounts. So, and then you can set up a new account like so. Now, I believe from memory that it's an Outlook one. Man, what is it? I think it's an Outlook one that you set up. Yeah, so from here, then you can log in using your @education email from that. Yeah, so you can log in using your @education email from there. Then, then it should be. Then I think that's kind of like the settings that you use, like so. I don't know, something like that. It's been a while since I've done it. How you doing, Ella? Thanks for coming. So yeah, today we can just kind of go through variables, right? It's a little bit scary because it's our kind of our first dabble into stuff with letters. So look, while you guys are waiting, I'd recommend that you kind of go ahead and watch these videos here, and then have a look at the questions that you need to do, and come back, and if you have any questions, let me know. Let me know. Alright, let's have a look at ones that there. What do you write from the sheet above the questions? You write this section here. So in the formula above, this one here. So we're starting to define what a variable is. Hey, Caleb. The last worksheet, yeah. So like it's just this. So this is the worksheet. So copy that down there, George, the one I've got highlighted there, that section. And then just doing this, right? So if you've watched the videos, it should kind of give you a bit of an idea of what you kind of need to do, like so. But yeah, if you need some help, if you need a further explanation, just let me know. We'll go from there. The camera won't take a photo of my work. Oh no. That's fine, Hals. If you want what can we do? The camera won't take a photo, I think. Frost Void. I don't know who Frost Void is. You got to tell me your name, mate. But morning. I'm not sure what we can do, Hales. So won't take a photo. Hey, Nate. Yeah, look, Hales, I'm not sure what we can kind of do about that. Hey. Morning, guys. Now remember, today... Hey, Taryn. Morning, guys. Thank you for popping in, hey? Good job. Well done. Hopefully, first period... What was first period? Whatever that was. Hopefully that was pretty easy for you guys. Today's a little bit tricky in the sense that we're kind of starting to mold how you look at numbers, right? For a long time, you guys have been used to kind of having problems, like actual problems, like in maths. Like you've been saying, all right, well, if I have 3 plus 2, it actually gives me a value. And we use... Algebra is not so much like this, right? Algebra is... Hey, PE, what a soft start. Algebra is not so much like this. Algebra is... Oh, is it called test? I don't know why I called it test. I'll have to change the name of the stream. Thanks for that, Will. Algebra uses these principles to simplify stuff, right? So instead of doing things like 3 plus 2, like what we had here, algebra is going and asking ourselves, well, 3 plus any number, right? Any number can equal any other number, all right? No, we're not having a test. Sorry, let me change the name of the stream. Let me not freak you out. Let me not freak you out. Let me just change the name. Edit. Let me change the name. Hopefully, let's call it Thursday Math, Year 7 at 10 and Year 10 at 11. There we go. There we go. Yes, you can relax. No, I changed the name. That was just a thing. So algebra is not so much about thinking, right, I need to get an answer, right? Algebra is very much about going, okay, well, if I add any number to 3, okay, this being any number to 3, I'm going to get another number. Like so, like really put... Cool. Okay. All right. I think we're back. I think we are back. All right. Cool. So, let's connect this back. Stop mirroring. Let's connect you back. Here it goes. Cool. So yeah, Will said a really good comment. So we're practicing this to enhance our numeracy skills in essence, right? But instead of just what we're doing is we're using our numeracy skills and reframing it in a different way by using this new language called like algebra, right? So if you've gone ahead and watched the videos, algebra is a new language that allows us to simplify things, allows us to simplify problems. Sorry, super laggy. We should be back now though, right? We should be back. It allows us to simplify things that can be quite long and complex, right? So the key terms are, and if you watch the video, you would have seen this, right? Something like if I have 3 multiplied by any number, like so, okay? In algebra, we want to be lazy, right? We want to write as least, no, yeah, I know. This is what happens, Phoebe, when you kind of run everything off Wi-Fi and off a school laptop, right? It's crazy. in maths, we're a bit lazy, right? Yeah, like what Dylan said, right? This one here is 3a. And this is the thing that gets a lot of people undone, right? Is that we're told that in maths to solve this. Well, actually, what we're actually told to do, and the verb that we're going to be asked to do things is to simplify, right? Because it's saying that we want to take something that's long, like this, and we want to make it smaller, like this. Okay, like so. It works in a similar fashion. We kind of do this in inherently anyway. Like if I had something like this, if I have 4 plus 4 plus 4 plus 4, like so, we can think of this in terms as 5 lots of 4, right? We take something that's long and we make it smaller. Algebra just goes ahead and does it the next level, right? And it communicates that pattern. In this instance here, it takes that 3 lots of A and it says, well, I've got 3 A's, like so. We can think of it in terms of like, Caleb, please be nice. Please be nice. She's okay. She's entitled to complain. It's all right. I'm flattered that you want to stick up. Yeah. So you just put them together like this. All right. So other examples like this. If I have x multiplied by y, it's going to just be x, y, like that, right? Another bit of notation that we need to know. Traditionally, we would have something like this, 3 divided by b, like that, okay? But in math, right, or particularly in algebra, you don't have to write this down, Hals. This is just an idea. I'll go through some answers. I'll go through the answers here with you in a minute. In maths, we can actually write it like this, like so. Thanks, Caleb. Very kind of you. Like so. So really, if you have a look at today's questions, okay, have a look at the verbs. In particular, the verbs are the things that what the questions want us to do. And our verbs say we want to simplify each of these expressions. This is the work that we're doing here, RL. I forget what your name is, RL. Hey, Zali. Hey, Mason. All right. We want to simplify. Now, I can hear some of you going, well, what the heck is an expression, right? An expression is just a mathematical statement without having to provide an answer, right? You think about an expression. Every single day, you wake up, you put on like makeup, you put on some clothes, you put on different things to express yourself, to make yourself feel good, right? And in maths, we call these things expressions, right? So we're going to simplify each of these expressions here. So let's think about each of these problems. Actually, I might cut this. I'll cut this and we'll pull this out so I can give myself some more space here. I'll take this row. I'll take this row like so. All right, here we go. So let's have a look at A over here, like so. Well, we're thinking about like this before. Let's think about this. Give me a tick. Sorry, Dylan. We're going to speak kindly of each other. Think about this before, right? W3, we can be tempted to say, well, it's just W3 like so, right? But what we tend to do, and what the proper notation is that when we're putting algebra together like so, is that we always put forward our number first, like so. So it's essentially saying, this is saying, I have 3 lots of W. Okay, and W doesn't have to be any specific value, it can be anything, because remember, we're looking here at patterns, okay? We're looking at taking this notation here, like so, and simplifying it, because that's our verb, simplifying it, to make it smaller and more efficient to work with, right? Now, over to this guy here. Now, this is in a similar fashion. The W can be anything. Like I said, Hals, we're not kind of so much looking at finding out what W is. This is not what this topic is about. This topic is purely about seeing a pattern and framing it in a different way. Okay, it's learning a new language. Let's go to here. Okay, I'll work down to 4 times f in a sec. Here, we can think of this as, well, how many have we got? 1, 2, 3, 4, 5, 6. Righto. We can say that we have 6 lots of A, just like in the similar fashion that I had, I rubbed it out, similar fashion that I had up there before, right? All right, 6 lots of A. But again, mathematicians are super lazy. So if we can write this in a much more simplified way, we will. So this 6 lots of A is essentially just saying, well, I've got 6 A's, like so. You can think of it like pictorially, right? Like if I have like, if someone over here has like, that's an apple, believe it or not. If this person here has paste, like so. This person here has 3 apples. This person over here has 2 apples, like so. Plus those guys together, like so. Well, how many apples do we actually have, right? We actually have 5 lots of apples, right? We have 5 apples, like so. Righto? So this is what's happening over here. This is saying I've got 6 lots of apples. Now, tapping into that, you can see down here, 5 apples. Yeah, exactly. You can see down here, if I've got 5m plus 2m, like so. Well, you can imagine this is exactly the same as what I've got down here. If I've got 5m's and I've got 2m's, well, my answer is going to be 7m's, like so. Okay? Thank you, Mason. Thank you. 7m's, okay? We're starting to get the hang of it, hopefully. Now, here comes the tricky part, okay? Because we have this problem here where we've got 2 of the same value which are multiplied, right? So an A in maths, yeah, it can stand for apples. When we can imagine these letters being anything. Do you write apples at the end or draw it? You can draw it. That was just a highlight. What I was talking about. Let's have a look at J, okay? This is 4 times F times F, right? It's this F times F. I want to think about this F times F. This F times F shouldn't be too, unfamiliar, right? Because we've explored this when it comes to indices. I'm hoping that you guys remember. Remember when we took 2 values like this, okay? And we asked you, not what the answer was. Again, we asked you to simplify this. Simplify. What was the answer for this, right? What was the answer for this? This here, of course, simplified, is 5 to the power of 2, right? Because we remember this from our index laws, like so. So over here, this is no different to using numbers as we are using letters here. So in this instance here, we can say we have 4 lots of F to the power of 2, right? We have 4 lots of F to the power of 2. Okay, hopefully that makes sense. Yeah, so you can express it like this, but, so you can go like this, F to the power of 2. Yeah, you can do that, Will, but that's probably the more correct answer. If we're simplifying it all the way, that's the form that we want it in, okay? Remember, whenever we have a letter and a number next to each other, or we have a number of letters next to each other, it always means multiply. All right, 16 divided by n, like so. Dimitri, dude, if you don't need to be here, don't be here, man. You're all good. You're right, Hales. I'll quickly go through these and I'll slow down the explanation a bit. All right. 16 divided by n, just like I said before. 16 over n, like so. That's that. Now, here's an interesting one. All right. H plus H minus a H. Righto? All right, let's have a look at this one here. Now, I'm going to go back to our apples, but this time let's do oranges instead, right? Let's do oranges instead. So, my question says that I have got a H plus a H minus a H, right? Now, let's look at this visually. So I'm going to draw one orange, like so. All right. I am then going to add another orange over here, like so. Okay. And then, what am I then going to do? It says, so I'm going to plus, and I'm going to take another orange away, like so. I'll copy that away. Well, you think about it, right? So up until this point here, you have two lots of oranges, but then all of a sudden you take one of those oranges away, we're just left with a single orange here, aren't we? There it is. We're just left with a single orange, righto? So here, thank you for the compliments. I was an art teacher. This is like conceptual art, right? Contemporary art. Thank you. You can see here, right? One orange plus a second orange gives me two oranges. All right. I then take one of those oranges away. I'm left with one orange here. So, given that's the way that we're looking at this, I'm running out of space here. Given that's the way that we're looking at this, if I start off with one H, I add another H, and then I take one of the H's away, how many H's have I got left? Well, I have just got one single H all by himself, like so. Okay? That's so. All right. Here is where things get a little bit tricky. Okay, look at this problem. This is a doozy here, right? This is an absolute doozy. So, what we can do... Good, I'm glad you got the house. Good job. Here's where multiplication gets a little bit tricky, right? So, what we're looking to do, okay, is we're looking to work with numbers that we can actually calculate, right? Now, if we recall from our commutative law, right? Remember our commutative law. Our commutative law says that we can take any of the numbers that are in a multiplication problem and we can swap them around, okay? We can swap them around. So this is what I'm going to do. I'm going to group all my my numbers together and rewrite this problem. So this problem here looks like 6 multiplied by -2, okay? Because there's that. All right. I am then going to multiply it by p here. Multiply by p here. Then I'm going to multiply it by my two r's. Multiplied by r. Multiply by r, like so, okay? Hopefully this is going to make things a little bit clearer. Now, looking at this problem here, what you can see is that we can actually start to solve some of these issues, or simplify, because that's what the question is asking us to do, to simplify some of these problems. Can we do 6 times -2? We can calculate that, right? We can absolutely calculate. 6 times -2, of course, gives us -12, if you remember your positive and negative numbers. We have our p here. We can say times it by p, like so. And remember, similar to what we did in j here, my r's are like so, right? It's multiplied by r to the power of 2, or r squared. Yeah, like so. Okay. We then go ahead and then we can simplify this anymore. We can simplify this again, right? In the same fashion that we looked at question A, right? Where all we did was just get rid of the multiplication. Okay. Where we look at the multiplication. My answer here is going to be -12 p r to the power of 2. Like so. Righto? Like so. Because you can see what we've done is we've gone ahead and we've removed these multiplications and we've simplified it even more into this problem here. Like so. Yeah, we're not kind of interested in what the letters equal. It doesn't really matter. What the letters equal isn't important. What we're looking at here is the patterns, okay, that it means, that it's expressing. So essentially, if we look at, it's glitched out again. Let's stop mirroring. Let's mirror you again. Super glitchy today. Super glitchy. Like so. Okay. Let's go back here. Yeah, it's glitching out. No, you don't need the letters equal to 1. So long as the thing isn't A, and all these letters can be anything we want them to be, right? So like I explained at the start, I can have 3 times A, okay? 3 times A can be anything we want it to be. A can be anything. It can be 3 times 1. It can be 3 times 2. It can be 3 times 3. It doesn't matter what A is. What we're focused on is we're focused on the language, okay? We're focused on creating developing a language that will enable us to simplify and express our patterns, like so. So the worksheets are going missing. Why have they gone missing? They should be there. Let me refresh. Should be there. We'll refresh. What the? What? Oh no, someone's moved it. One of the teachers have moved it. There it is. I've put it back. There it is there. That's where it was. Alright, cool. It's gone up here, like so. Alright. Yeah, so it doesn't matter what the letters are. The thing to note, though, is that if you have a problem that has multiple letters in it, like let's say if we have 3 times A times B, like so, okay? The reason why we have different letters in a problem like this is to indicate that A and B are going to be different numbers, okay? So this here, 3 times A times B, okay, is not going to be equal to something like 3 times 2 times 2, okay? Because, of course, A and B are different. Alenia, yeah, I just fixed it up, mate. Hopefully it should be back. It should be back. So what happened was someone's rejigged it. So I've just moved variables back up to where it was. Yeah. So yeah, so here, not AB3, I forget who me is. What it actually is we will always put our numbers first. So this instance here, to simplify this, will be 3AB, okay? Great idea in getting rid of the multiplication symbols here, all right? It's not to say that AB3 is incorrect, all right? It's kind of like, in a sense, that the reason why we put the numbers first and then these guys in alphabetical order, it's kind of like a universal language that we use, right? Like whenever we write books, whenever we read stories, we read from left to right. Does it make sense? So in maths, whenever we're talking about algebra and expressing ourselves in terms of algebraic terms, we'll always have the numbers, the number first, and then the letters like that. It's one of those just like basic laws that if everyone agrees to do it that way, it's much easier for everyone else to read, like so. Oh, shivers. That's better. Helps if you guys can see. Yeah. Cool. All right. So you can see today, right? We've moved really well beyond. Yeah, numbers always go before the letters in the answer. Yeah. we're moving well beyond just solving problems of like 3 plus 2 equals 5, right? We're thinking well beyond, we're breaking the shackles of maths and we're introducing a brand new language. We're using these old ideas, right? We're using these old ideas of adding and subtracting and things like that. Those things haven't gone away, and I don't want you to forget them. And that's why, in particular, we focused on at the start of the lesson and the past 2 lessons that we focused on these 3 laws here. Okay, these 3 laws here still apply. Understanding commutative, associative, and distributive laws are still there, right? Now, instead of thinking of it in terms of, all right, I just want to get the answer, because you guys are so used to kind of just, I want the answer. What's the number? What is the end goal? If I have one and I add another one, what is it going to be? This is not what this is about, right? This is about taking expressions. This is about taking math problems that are extremely long in the similar fashion to here and devising ways which we can simplify them, right? Devising ways that we can simplify them, like so, like so, like so, like so, like so, is equal to 5a, like so. That's what we're about, okay? That's what it's about. All right. If you haven't already, do the letters have to be in alphabetical order? It's a good habit to get into. Yes, I would say yes. It's a good habit to get into. If you haven't already, I would highly recommend that you watch these 2 videos as well. Number, then rearrange the letters that follow alphabetical left to right, i.e. B. Yes, perfect, yeah. Mr. Miller's nailed it. Could it just be like A? No, can't be just A. The reason why it's not A, remember, when we have 2 letters next to each other like that, it means multiply, right? Just like, so if I have A, this, what you're communicating to me is this. Okay, that's what you're communicating to me when you're writing it like that. In similar fashion, if I did A, B, C, D, and E, it would be, you'd be communicating this to me. C/D times E, like so. Because remember, like my example I had up here, right? Like my example up here, I can simply say, and I'll do this in red, okay? This top one here, this is 5 lots of 3, right? And we know lots of equates to times. Just like underneath, this is 5 lots of A, like that there, i.e. 5A. How long have you been around for, Ella? Since the start? Because I can start again for you if you like. Not that long. Okay, cool. That makes sense why you'd be really confused. Okay, because I've kind of been going on for a little bit. All right. So, for those guys that have come late, I'm gonna kind of start again. Well, not so much start again. All right. This one's for you, Ella, and for anyone who kind of missed out at the start a little bit. So, up until this point in maths, right? Oh, shivers. Thank you for reminding me. It's going to drop out again. Of course it is. No, there it goes. All right, cool. So for those of us who missed out beforehand, all right, I'm going to kind of start at the start again. All right. For a long time in maths, right? For pretty much most of your entire mathematical journey, from kindergarten right through till about now, okay, you guys have been presented with problems that require a specific answer, right? The sheet should be there, Mr. Miller. The sheet should be there. The sheet should be there. Good job, Zali. Killed it. Great job. Did you understand it? Hopefully you understood it, mate. The sheet should still be there. Just refresh the classroom. Give that a second to refresh. All right. Good job, Zali. Well done. For a long time, we've been posed with problems like this. You'd be asked to go, well, what's 5 times 2? Well, it equals 10. What's 3 plus 4? Well, that equals 7, right? It was a beautiful world because it was nice and simple. We simply just... Man, things are lagging really bad today. Things were just quite simply, here's my problem, I'm going to get an answer to it. Checking your answer there, Haley. However, what we're focused on here when it comes to algebra is a new way of imagining these problems. We're not so much concerned, particularly at this step of algebra, about what the answers are, okay? We're considering and thinking about a new way to communicate our ideas, right? For example, we've been doing it already. If I take something like this, 5 plus 5 plus 5, let's just do one more, plus 5, okay? Yes, Haley, you did. Nailed it. Perfect. Good job. Well done. This here, we've already done this. We've already reimagined this as saying, well, this is the same as saying 5 times 4, right? Okay. This is kind of like 5 lots of 4, which is the exact same as this. 5 lots of 4. We've been doing this for a long, long time. What algebra does, okay, is it goes ahead and says, right, well, let's take this idea, and instead of just having, if I just have like 5 plus I don't know how many numbers, how can I express that, right? And this is where algebra comes in play, because algebra is simply about saying, well, it's going to be 5 lots of any number, where A can be any number, right? Like so. We take something, we take a pattern that we can see and we're reimagining it in a different way. Now, algebra doesn't only just stop at this, however, okay? It simplifies it even more, because sometimes writing a million different multiplication symbols can be really, it can mess with your mind. Like, let's have a look at this. It can be really hard to read. Let's say I have 5 times 6 times 8 times 4 times 5 times 7 times 2. Like, you can see is it's really kind of really long and really painful, right? What algebra does is it simplifies that. Let's say, for example, that I have, let's start with this one here, A plus A plus A plus A, like so. Let's do that. Now, we know that this here is to be 4 lots of A, right? As we kind of explained and highlighted up here. Similar fashion to how it works at the top here, right? Give me a tick, Haley. I'll finish this explanation, then I can help you out with some specific questions. However, in algebra, what we actually do is we go, rather than doing 4 times A, we simplify it even more and we say, all right, well, we're going to do 4A just on itself, just on its own, like that. Simply, these things all mean the same thing, but when we are simplifying, we're asking ourselves, well, which requires the least amount of writing? Well, ultimately, it's this guy here, like so. So we're taking what we've known before and we're applying it to a different language. We're taking what you've done and it's a brand new language, a brand new set of ideas, and a brand new approach. Yeah, Dimitri, good answer. Perfect. 5, then it'd be 5 over E, yes. All right. Hopefully, Ella, that makes sense. Hopefully you're still here and that makes sense. All right. Haley, let's have a look at some of these other questions down here. Okay. use order of operations to simplify each of these expressions. So let's have a look what's happening here. Okay, let's have a look what's happening here. Is this all on the worksheet? No, so I'm writing on the worksheet. So you can have a look at a few examples. Remember, you can use these examples. If you come across problems up here, here's example 7 up the top here, right? It says, if you don't know how to simplify D8, not only does it tell you the answer here, but also over here, it gives you an explanation of how to do it as well too. All right, so you can use those solutions there. All right, use these solutions to help guide you. Watch the videos, Ella, and go from there. All right, let's take this question down here, and we'll go through a few of the questions, just like that. Okay, so is there any question in particular that anyone's stuck on? Oh, paste image. Is there any particular question here that anyone's stuck on? Good job, Ella. Phoebe, this negative self-talk doesn't look good on you. Okay, let's have a look at this problem here. Now, this is all about order of operations. Hopefully, you guys can remember your order of operations, right? Remember, order of operations dictate that we do our brackets first. Okay, solve everything in our brackets first. Then we do our powers, okay, or our indices, or index. All right. Then we do our multiplication and division. And then finally, our addition and subtraction, like so, in order. Now, having a look at 16, having a look at 3A here, okay? Let's have a look what's working here. Well, the first thing that I can see is I've got myself my brackets here. So that's what I'm going to solve first, righto? So 3A. My first step looks something like this. 16 divided by, well, A times 5, we've already understood that this is 5 lots of A, okay? 5 lots of A. So it is 5 lots of A, because remember, we did this in the previous questions like that, okay? From here, this is not the most simple way we can express this though, is it, righto? We can go ahead and we understood that, well, this division symbol here, we can express like as a fraction, like so. So here we can say that it's going to be 16 divided by, I'll zoom in so you can see, 16 divided by 5A, like so. Okay, like so. Yeah, question number is algebra, true that, funny. All right, let's have a look at question B. Now, question B says, okay, 7 plus 3 times n. Well, let's have a look here. Do we have brackets? No, we don't have brackets in this problem. Do we have any indices? No. We do have a multiplication here, don't we? We have 3 times n. Now, let's go ahead and write that. Let's go ahead and simplify this again. So I'm going to write 7 plus, well, we know when we simplify 3 and a number, okay, it is 3n, like so. And from then on in, I can't really simplify it anymore, right? Because this is kind of like my order of operations. I don't know what n is, so I can't add 7 to this, because if I go ahead and I see you guys, see ya. All right. Hopefully that makes sense. Hopefully that clears it up. Hopefully you got something from this. If you need some extra time, if you need some extra help, just message me, send me an email, do whatever you need to do to communicate to me that you're struggling and need some help. Okay? I'll be hanging around for a little bit longer because Year 10 are going to be on here in a minute. So if you want to spend the next kind of little bit doing some stuff or answering questions, you can do that. My legal obligation to be here is ended. I'll go you, Phoebes. Maths loves you. That's the problem, Phoebe, right? Like, you're actually good at it. See you, Dimitri. Good job, mate. Thanks for your help and helping out other people here too. Really good job. Contributed really well. No worries, Ella. Thank you for asking some really good questions. Thank you for asking some really good questions. Good job. If you want to hang around with year 10, you could do that. That's fine. Look, I don't know what you've got, but look, you probably should go to your next one. But you can maybe just keep the stream open if you want, right? Alright, let's check my emails. I haven't checked it. What's the code? Vincent. Don't understand any of it. You understood the earlier stuff though, Haley? You too, Ella. See you, mate. I still don't understand most of it. Okay. No, well, I don't sell yourself too short though, right? Because if we go back up, like a lot of this stuff here, you kind of really begun to understood that, right? Like so don't sell yourself short. Like this here is that first battle. Thanks, Mr. Miller. Don't sell yourself short, right? Like here you understood that this is 3W. Okay, so that's good. That's good, right? Like this is saying this is just changing the way, like to put it in use another analogy, right? It's kind of like, when someone, like when we use like slang, all right? If I say hello, all right, that's the another way of saying g'day, right? This is the kind of battle that we're struggling. Like unless you know what that actually means, all right, you can only with practice will you begin to understand it and recognize that these two things are exactly the same. Just like here in maths, right? Like we're understanding that we're taking something that we know to be true. We know that any number times by 3 can be anything, right? This is how we frame it. Oh dear. Oh yeah, I am too. I am glitching. Give it a second. Give it a second. Give it a second. Are we back? Hold tight. Still, give it a second. All right, let's see a house, hopefully. All right. Anyway, such a tricky topic, right? Such a tricky topic to be dealing with. All right, we will. All right, we're gonna end this stream, I think. We'll end that stream.